Right? Go, that's so we're staying in.
Hey guys, it's Albert, calculus business student. We're gonna help you guys to learn geometry. Let's get to it. Alright, hey guys, so we're back and so we're gonna talk about ratio and proportion. So as you can see, the ratio of one number to another is the quotient when the first number is divided by the second. This quotient is usually expressed in simplest form. So let me draw a triangle for you. So this is the first triangle. What a nice triangle, right? Okay. So the first one we're going to call it A, B, C. And the second one is going to be A prime, B prime, and C prime. Okay. So, like let's say for example A, B is 4, 5, and 6. Just trying to record the size. Right. So I want to write the ratio of AB to A prime. So what I'm trying to do is I'm trying to compare the length of AB and A prime B prime, right? So what I'm going to write is 4 to 8, right? That would be the ratio because I'm comparing the length of these two sides. Let's do some angles, right? Let's do it. Like we have the ratio of C to C prime is 30 degrees and 60 degrees. Okay. So that's pretty much how it works, So, we have these ratios, and the ratio is the comparison between two numbers. It could be anything, It could be the length of something, It could be the size, it could be the weight. So pretty much ratio is comparing two different things, okay? Let's get to simplification of ratios. Sometimes, you come to the point that you have to simplify your answer. So let's get to it. Okay, so for example, we have 12 to 20, okay? We can easily divide 12 and 20 by 2, which would be 6 to 10, and then we can still simplify it, and then so it's going to be 3 to 5, okay? So try to simplify your answers as much as you can because it's going to help you, in future, okay? Because sometimes you come to the point that you have to simplify like big numbers, and you just don't want to mess up your work. All right. So what about sometimes that, for example, there's a letter in our ratio. So as you know that, like for example, I've written here is 3p over 5p. The p on the top is equal to the p on the bottom, right? They're identical, so I can easily just get rid of them and then simplify the answer to 3/5. Same thing as exponents, right? So for example, here we have n squared and then n cubed. I know that n cubed is equal to n squared times n, right? So I can easily get rid of the n squared, and then I'm going to be left off with n. So the final answer is going to be, alright, sorry guys, so it would be n squared over 4n, so you know that I can say that n squared is equal to n times n, right? So at the bottom, the answer is 1.
Hi, I'm Troy, and I'm in Calculus BC. I took geometry when I was a freshman, so I'm going to be teaching you guys about cross-multiplying and ratios. So first we are going to be learning about properties of proportions. Now, these proportions can be written many different ways. Now, first you start off with the proportion of A over B equals C over D. Now, this can be written different ways and mean the same thing. Now, one way is if you cross-multiply, you multiply diagonally, it equals AD, which equals BC. That's one way it can be written, and another way it can be written is A over C equals B over D. Now, there's another way you can write it, and if you just cross multiply again, it'll come out to the same thing, which is AD equals BC. Now, since you can write them the same way, there are many different ways that they can be put together to equal the same thing. Now, if you start off with the equation 4 over x equals 2 over 5, and you cross multiply, you multiply across, you get 2x equals 20. Now, divide the 2 on both sides, and you get x equals 10. Now that's one way of using cross multiplication to solve a problem for a proportion that you do not know. Now another problem we have here is x plus 3 over 2 equals 2x minus 1 over 3. Now on this one, you're going to have to FOIL it out after you cross multiply. Now, you cross multiply here, you get 3 times x plus 3. That equals 2 times 2x minus 1. Now you have to multiply across to make sure you don't forget any term. 3 times x, 3 times 3, and then on the other side 2 times 2, 2x, plus 2 times negative 1, which gives you 3x plus 9 equals 4x minus 2. Now you put like terms on the opposite sides and subtract. You get 9 equals x minus 2, and add 2 to both sides, and you get x equals 11. That's your answer. Okay, so now we're going to be talking about similar polygons. What you need to know about similar polygons is that two polygons are similar. Their vertices have corresponding angles and they're congruent, and corresponding sides and they're in proportion. Now, here you have two polygons, so you set the two smaller sides, 15 over 20, and the two top sides, which you have 21 over x. Now, you just need to cross multiply, and you get 15x equals 420. Now you divide by 15 on both sides, and the answer you get is x equals 28. Now that you've solved for one side of the polygon, you have to continue on to the next one. So there, you put in x equals 28. So the next side, you can do the sides, where you use the same proportion to make it easier, and you have 15 over 20 equals 18 over y. Those are the two sides that are proportional to each other and look the same and have the same proportion. Now you use the same, where you have 15y equals 360. Once again, you divide 15 across, and your final answer, y equals 24. Now that you've solved for three sides of the triangle, you can continue on and solve for the last one. Now, you can continue to use the same proportion you started with on the first one, or you can use one of the ones that you just solved for. However, it's much easier to use the initial proportion. So I start again with 15 over 20, and that equals 27 over z. Now, once again, you cross multiply, and you get 15z equals 540. Now, once again, you divide by 15, and your final answer will come out to be z equals 36. Now you've solved for all the sides of the polygon, and that's how you solve for similar sides on a polygon.
Hello, I'm Jason. I'm also a calculus BC student, and I will be teaching similarity theorems.
Alright, so guys, we're going to start off with the angle-angle similarity postulate. Sorry, let's write angle-angle up here, or AA for short. And so basically it's pretty simple. All you need to know is that if two angles on two different triangles are congruent, then the angles are the same. So you can see here that these two angles are both 90, so that's one. So all you need is one more. And since you know that these two angles are going to be the same, so yeah, if you assume that those two angles are the same, then you know that these two triangles are going to be similar. So you know that the third angle of both triangles will be congruent, and that all the sides will be in proportion. So yeah, that's the angle-angle similarity postulate. Alright, so our next similarity postulate is going to be the side-side-side. And that, basically all that means is that if three sides of one triangle are proportionate to three sides of another triangle, then the triangles will be similar. So to test that, here I've drawn these two triangles, one with sides 15, 18, and 10, and another with 9, 10.8, and 6. So we take side AC over side DF, and side AB over DE, side BC over EF. So basically, longest over longest, shortest over shortest, and middle over middle. And then, so here we're gonna finish this, and then once we get, so AC over DF is going to be 18 over 10.8, and you can just 10.8. Okay, and then you can just trust me and assume that that is 5/3. And the next one is AB over DE. That is 15 over 9. So let's write 15 over 9. Yeah. And that will also equal 5/3. Hooray. We know that those are in proportion now. So all we need to know is the third side, which is BC over EF, which is 10 over 6, which hopefully you can do the math and figure out that is 5/3. Yay. All right, that is the side theorem. So now you know that all of the angles in those, or the three angles in those triangles will be congruent to the proportionate angle. All right, so the last similarity postulate we're going to do is the side angle side, or SAS. And it's important to note that the A is in the middle because when you're doing this postulate, you have to make sure that the angle you know is in between the two sides that you know. So you can see here that the 90-degree angle is in between the two sides with values. So that means that we can actually do this postulate. So here we're going to say that angle B is equal to angle E. So just so we know that that is our angle between our two sides. So now we're going to take AB over DE because those are hopefully going to be our proportionate sides. And we're also going to take BC over EF, which will hopefully also be proportionate to prove that this is SAS. So AB over DE is going to be 6 over 4, and BC over EF is going to be 3/2. BC over EF is going to be 3/2. So we know that 6/4 is pretty clearly, it reduces down to 3/2. So we know that AB over DE is 3/2 and BC over EF is also 3/2. So we know that they're in proportion, and we also know that angle is between them they're equal. So we know that these two triangles are similar. So we know that the third side on both will be proportionate, and that the other angles will be equal. Because they're similar. Don't know what I'm writing here. Yeah. All right. It's fine.
All right, guys, we're back, and let's get started. So we're going to cover Chapter 7, Section 6, proportional length. And the first theorem that we're going to cover is triangle proportionality theorem. So what this theorem says is that if a line parallel to one side of the triangle intersects the other two sides, then it divides those sides proportionally, right? Let's get started. All right, so we're going to draw a diagram. So it would be RPT, QS,
so
the angles. Okay.
we're given.
All right. So first off, we're given that in triangle RST, line PQ is parallel
and we
to
know
RS.
That the line PQ,
right?
This line here,
This is given to us.
it's parallel to RS, right? As you can see, these two are parallel.
So what we have to prove is that we have to prove that RP over PT is equal to SQ over QT. You guys remember?
All right.
So the ratio of RP over PT is equal to the ratio of SQ and QT. All right. That's what we got to prove. Okay. So let's get started.
We know that these
So we know that PQ is parallel to RS, and my friends, I've already taken care of these. They have already told you that when two lines are parallel to each other, angle 1